Hello guys, welcome to another episode of #Learn with Rhea. And for today's episode, we will learn how to solve linear differential equation. Without further ado, let's start. Linear differential equation is an equation of the first degree only in respect to the dependent variables and its derivatives. A DE is said to be linear if dependent variable and its derivative are of degree 1, coefficients of a term does not depend on dependent variable, and if the given differential equation can be expressed in the form dy over dx plus p of x times y equals q of x if it is linear in y, and dx over dy plus p of y times x equals q of y if it is linear in x. And after, there are formulas to use in order to solve for the linear differential equation. If it is linear in y, we have to use the formula y times e raised to the power of the integral of p of x dx equals to the integral of q of x times e raised to the power of the integral of p of x dx. And if it is linear in x, we have to use the formula y times e raised to the power of the integral of p of y dy equals to the integral of q of y times e raised to the integral of p of y dy. Let's try some examples. So example number 1, we have x times dy over dx plus y equals x cubed. So we can see in this equation that this is dependent in y. So we will transform this into the form linear in y. Linear in y, we have dy over dx plus p of x times y equals q of x. So we are going to do what we are going to do here. Wait, let me just copy this. So we will divide this first by 1 over x. So we have dy over dx plus 1 over x times y equals x squared. So we have now the form in linear in y. So we will use the formula, which is y times e raised to the power of the integral of p of x dx equals to the integral of q of x times e raised to the integral of p of x dx. So we will now then substitute. So because we have now in the form linear in y, dy over dx is present, our p of x and our q of x. So y times e raised to the power of p of x, which is 1 over x dx equals to the integral of q of x. Our q of x is x squared times e raised to the power of 1 over x dx. So we will then integrate. We have y times e raised to the integral of dx over x equals to the integral of x squared times e raised to the integral of dx over x dx. So proceed, we will now have y times e ln of x equals the integral of x squared times e raised to the power of ln x dx. So ELN will be cancelled. So we are now left with yx equals to the integral of x squared times x dx. So this will become x y equals integration of x cubed dx. So we will now integrate this one. We have xy equals x raised to the power of 4 over 4 plus c. So this is now our answer to the given linear differential equation. But sometimes this one can be expressed in y. So we have y is equals to x4 raised to the power of 4 over 4x plus c over x. Simplify, we have y equals x cubed over 4 plus c over x. So this still can be the answer for the given linear differential equation. So example number 2, we have x plus 3y dx minus x dy equals 0. So since we cannot identify what is the dependent variable here, we distribute dx. So we will have x dx plus 3y dx minus x dy equals 0. Then we will arrange this one. We then have x dy minus x dx minus 3y dx equals 0. We will then divide this one by 1 over dx. So we will have x dy over dx minus x minus 3y equals 0. We will then equate this equation into x. We will then have x dy over dx minus 3y equals x. So we will divide this now by 1 over x. So we will have dy over dx minus 1 over x times 3y equals 1. So in the form linear in y, we have to isolate y alone. So we will then have dy over dx minus 3 of x times y equals 1. So we can identify that this given equation is dependent in y. So we will use the form linear in y. So we have dy over dx minus 3 of x times y equals 1. So our p of x and our q of x. We will now then use the formula for the linear in y. So for the formula for linear in y, we have y times e raised to the power of the integral of p of x dx equals the integral of q of x times e raised to the power of the integral of p of x dx. So we will substitute because we have our p of x and our q of x. So y times e raised to the power of the integral of p of x, which is negative 3 over x dx equals to the integral of q of x, which is 1, times e raised to the power of the integral of negative 3 over x dx. So we will now put the constant outside the integral sign. Then we will have y times e raised to the power of negative 3 integral of dx over x equals the integral of e raised to the power of -3 integral of dx over x dx. So we will integrate now. We have y e raised to the power of -3 ln of x equals the integral of e raised to the power of 3 ln x dx. As rules for the natural logarithm, we will make this one into an exponent. So we'll then have y times e ln x raised to the power of -3 equals the integral of e ln x raised to the power of -3 dx. So e raised to the power of ln will be cancelled. So we are now left with y x raised to the power of -3 equals the integral of x to the -3 dx. So we will integrate this one. We have now y x raised to the power of -3 equals x raised to the power of -2 over -2 plus c. So this is now the answer for the given linear differential equation. Woo!